Remote sensing systems. The common remote sensing system are of two types, imaging and non-imaging. Image formatting system are again of two types, framing type and scanning type. In scanning type, the information is acquired sequentially from the surface in bit of picture elements of pixels, point by point and line by line, which may be arranged after acquisition into a frame format. Remote sensing can be either passive or active. Active systems have their own surface of energy, such as radar, whereas the passive system depend upon external source of illumination such as sun for remote sensing. Platform and sensor. The information flows from an object to a sensor in the form of radiation transmitted through the atmosphere. For a sensor to collect the record energy reflected or emitted from a target or surface, it must reside on a stable platform away from the target or surface being observed. Based on its attitude above Earth's surface, platform can be classified as ground-borne, airborne, and spaceborne. Spaceborne platforms are in space moving in the orbit around the Earth. It is through the spaceborne platforms we get enormous amount of remote sensing data. Depending on their altitude and orbit, those platforms may be divided into categories. Geostationary satellites. An equatorial west to east satellite orbiting the Earth at an altitude at which it makes an revolution in 24 hours, synchronous with the Earth rotation. Hence, it gives continuous coverage over the same area day and night. Those are mainly used for communication and meteorological application. For example, the INSAT satellites. Polar orbiting or sun-synchronous satellites. A satellite which include north-south orbit track westwards at a rate such that it covers each area of the world at a constant time of the day, called the local sun time, as the satellite moves from north to south. They ensure the similar illumination condition while acquiring image over a particular area over a series of days. On the descending path from north to south, the satellite travels on the sun, its side of the earth, while on ascending path from such to north, it travels on the shadowed side of the earth. Through the satellite, the entire globe is covered on regular basis and gives repetitive coverage on periodic basis. All remote sensing resources satellite may be grouped in this category, for example IRS series. Sensor is the device that gather energy, convert into a signal and present it in a form suitable for obtaining information about the target under investigation. Sensors used for remote sensing can be broadly classified as those operating in optical infrared region and those operating in microwave region. Optical infrared and microwave sensor can further be subdivided into passive and active depending on the sources of energy. Active sensor use their own sensor of energy to illuminate Earth's surface and a part of it is reflected and received to gather information. Passive sensor do not have their own source of energy but instead receive solar electromagnetic energy reflected from surface or energy emitted from surface itself. Hence it cannot be used at night time except thermal sensors. Energy that is naturally emitted can be detected day or night, as long as the amount of energy is length enough to be recorded. Type of remote sensing. Remote sensing can be broadly classified into three types with respect to the wavelength region and type of sensor involved for data acquisition via optical, thermal, infrared, and microwave. In present study, optical remote sensing technique has been used to achieve the defined objectives. Optical remote sensing. Optical remote sensing involves the use of visible part of the EM spectrum energy emitted from sun is used for visible and reflecting infrared remote sensing. The Internal Commission on Illumination has defined the visible spectrum to be from 0.38 to 0.79 nanometer. The human eye has a peak sensitivity at 0.55 microns, which is approximately the peak of the emission curve of the sun. Remote sensing data obtained in the visible and reflective infrared regions mainly depends on the reflections of objects on the ground surface. Therefore, information about objects can be obtained from the spectral reflection. Thermal infrared remote sensing. The source of radiant energy used in thermal infrared remote sensing is the object itself, because any object with a normal temperature will emit EM radiation with a peak at about 10 nanometer. Microwave remote sensing. In micro region, there are two types of micro remote sensing, passive and active. In passive microwave remote sensing, the microwave radiation emitted from an object is detected, which in active microwave remote sensing, source of EM radiations and detector are placed on the sensor. Inherent characteristics and spectral signature of object. In any photographic image forming process, the negative is composed of tiny silver deposit formed by the action light on photosensitive film during exposure. The amount of light received by the various sections of the film depends on the reflection of EMR from various objects. The light after passing through the optical system gives rise to different tones and textures. In visual interpretation and interpreted is primarily concerned with recognized changes in tonal values, thereby differing on object of an Christian reflective characteristics from another. However, he must be aware that the same object under different moisture or illumination condition and depending on the wavelength of incident energy may reflect a different amount of light. For this reason, a general key based on tone characteristics of object cannot be prepared. In such case, other characteristics of objects such as their shape, size and pattern etc. help in the recognition. Spectral signature is the parameter which determines the character of the object under observation. This can be defined as a unique pattern of wavelength radiated reflected by an object. It can be categorized as spectral variation, variation in reflectivity and emissivity as a function of wavelength. Spatial variation, variation in reflectivity and emissivity with spatial position. Temporal variation, variation of emission and reflection like that in diurnal and seasonal cycle. Polarization variation, variation are introduced by the material in the radiation reflected or emitted by it. Each of the four features of EMR may be interpreted a measure of the variation and correlation. The known feature of an object provides signature of the object concerned. The knowledge of the state of polarization of the reflected radiation in addition to spectral signature of various objects in remote sensing add a dimension for analysis and interpretation of remote sensing data. Those parameters are extremely useful in providing valuable data for describing the object. Elements of image interpretation. Recognizing target is the key interpretation and information extraction. Observing the difference between target and their background involves comparing different targets. based on any or all of the visual element of tone, shape, size, pattern, texture, shadow, and association. Identifying target is remotely sensed image based on this visual element allows us to further interpret and analyze. The nature of each of those interpretation element is described below. Tone refers to the relative brightness or color of object in an image. Generally, tone is the fundamental element for distinguishing between different targets or features. Variations in tone also allow the elements of shape, texture, and pattern of objects to be distinguished. Shape refer to the general from structure or outline of individual objects. Shape can be a very distinctive class of interpretation. Straight edge shapes typically represent urban or agricultural targets, while natural features are generally more irregular in shape. Size. If object in an image in a function of scale, it is important to access the size of a target relative to other objects in a sense, as well as the absolute size to aid in the interpretation of that target. A quick approximation of target size can direct interpretation to an appropriate result more quickly. Pattern refers to the spatial arrangement to visibly discernible objects. Typically, an orderly repetition of similar tones and texture will produce a distinctive and ultimately recognizable pattern. Structure refer the arrangement and frequently of tone variation in particular areas of an image. Texture would consider of a model tone where the gray level change abruptly in a small area, whereas smooth texture would have very little tonal variation. Shadow is also helpful in interpretation as it may provide an idea of the profile and relative height of a target or targets, which may make identification easier. However, shadows can also reduce or eliminate interpretation in the area of influence, since targets within shadow are much less discernible from their surroundings. Association takes into account the relationship between other recognizable objects or feature in proximity to the target of interest. The identification of features that one would expect to associate with other feature may provide information to facilitate identification.